So let's try and run this function for a few values. Suppose we tried this with n equal to 4. We say, well, the sum of the numbers from 1 to 4 is 10. Let us say for some reason we think that this code is incorrect. Let us say we believe this function actually returns the answer 20. When we click on code check, it will tell us that sum2 of 4 does not return the value of 20. So this particular function is actually correct on the input 4. Once again, if I just change the return value to actually 10, then the feedback I will get actually confirms that the function works correctly when n is 4. Once again, remember, the idea of a refute problem is for you to give me an input on which this function actually fails. So think about what that counterexample input might look like. So here's an example of an input that this code will fail on. Let us say we try the input -3. Now for -3, what is the expected answer? Well, we're once again talking about an empty summation. We want the summation from 1 plus 2 plus 3 all the way up to -3. So there are no numbers over there. So the expected answer there really should be 0. Just like in the case when we were summing up to -1. Again, that's an empty summation, so we should follow the same logic. But what does this function actually return when n is -3? Well, firstly, it calculates n plus 1 because that's in the innermost brackets. So -3 plus 1 is -2. And then it takes -3 times -2, which is of course 6. And it divides that by 2. So this function actually returns 3. If we're correct, then this is a counterexample. And indeed, we have got the success message. So just blindly calculating n times n plus 1 by 2 is not the correct answer. I'm sure you can debug this code. Please handle the situation when n is negative, and only if n is greater than or equal to 0 should you apply this formula. Now it turns out the formula actually does work even when n is -1, but for every other negative number it will fail.